Hey, the second half of our review today. That means we are like done with 6th grade. Isn't that crazy? So this is the last thing that I'm really going to be teaching you guys. We may be doing other activities, but this is kind of like the last more formal lesson. And it's review, so less stressful. Like we've been doing throughout the unit, it's really helpful to refer to the different types of transformations. I'm not going to be going back to this image back and forth, but you are welcome to be looking at this image for every single question you do. And what I'm going to ask you to do is to go ahead and pause the video, complete the whole assignment, and come back when you're ready to hear me go over everything. Okay, let's do it. So my assumption is that you have completed everything and you're just checking your answers with me. And I'm doing all these questions live, so if it takes me a second to read the problem, that's why I haven't read them in advance. So let's see. So we know information about the perimeter and the area, and we know that it's dilated by a scale factor of 1/4. So what do we know about the perimeter and the area? So dilation means that the two figures are similar. And that doesn't look right. Similar. Yeah, okay. So when you are dilating something and when you have similar figures, the perimeter, whatever happens to the scale factor happens to the perimeter. So if the scale factor is 1/4, that means things are being divided by 4. That's what's going to happen to the perimeter. So right away, I can say that the perimeter of 40 centimeters, I need to multiply by 1/4. In other words, divide by 4. Perimeter is going to be 10 centimeters. So I can eliminate these two guys. The area is affected by the scale factor squared. So 1/4 squared is 1/16. So instead of dividing it by 4, I have to divide it by 16. So times 1/16 or divide by 16, it's the same thing. And 96 divided by 16 is 6. 6 centimeters squared, which leaves us with A as the answer. Okay, next one. So we want to know what's happening with a scale factor of 3. And the origin is where the explosion of the dilation is coming from. So typical rules. So that means I'm multiplying everything by 3. And if I take, they want point P. Okay, so I need to multiply those numbers by 3. So it looks like D is going to be my choice there. Next problem. Study it. I don't know if I want to study it. I might just do the problem. I'm very funny. So let's see. So we have translated 4 units down. What are the coordinates of T prime? So the original coordinates of T are -1, -4. Translating something 4 down means that X stays the same and Y becomes 4 less. So T prime means X stays the same, and take away 4 from -4. That gets me to -8. So C is going to be my answer there. All right, so we're rotating something around the origin. That means it's a normal rotation. What statement must be true? Side lengths don't get doubled because in a rotation, it creates a congruent figure. So that's same size, same shape. So the side lengths can't change. That's only for dilation. The area of the polygon did not change. That seems true. The coordinates did not change. Nope. Coordinates will change in a rotation. And the area is 4 times its original. No, because it's the exact same shape, just somewhere else on the grid. So B is the only true one. All right, 3 transformations will be performed on triangle ABC. What will produce a congruent triangle? So that means we basically want the 3 isometries. And we basically don't want a dilation included. So these 3 all have dilation in it. So D is the only one that lists all 3 isometries. A dilation will make it similar but not congruent. Okay, which figure has a line of symmetry and rotational symmetry? Now, we didn't talk about rotational symmetry. But maybe you could figure it out. Basically, it means if you spin the figure, it stays the same. So A, that one looks like the only one you could really spin and keep getting the same figure over and over. So I think that's the only one that'll work. And as far as a line of symmetry goes, I really only see like A has a line of symmetry there. C has a line of symmetry there. So you could fold it and it'll stay the same. B, let's see, would this create a line of symmetry? That might create a line of symmetry. D definitely doesn't have a... Oh, no. D, I guess you could actually say this is a line of symmetry. So they all potentially have a line of symmetry, except maybe B. Not sure that B would actually be symmetric if I folded it there. So A, C, and D all have a line of symmetry. But I'm going to eliminate C and D because you can't rotate them and keep them the same. A is the only figure you could rotate and keep it the same, like a flower or a circle. So that one happened to be a question we didn't really talk about, so don't worry about that if you didn't get that one right. So let's see. We're translating it 1 down and 3 to the left. So if I just focus on like A, for example, A is 2, 1. Translating it 1 down and 3 to the left. Well, 3 to the left means my X is being decreased by 3. 1 down means my Y is being decreased by 1. So A is going to become D. And 2 minus 3 is negative 1. 1 minus 1 is 0. And it looks like choice D is the only one that has that as an option. And you could check the other 2 points as well. But choice D seems like that's the answer. Okay, so we're rotating at 100 degrees. And what are the new coordinates of A prime? So first of all, A has coordinates at 5, 4. The rule for rotating at 180 degrees is you take the opposite of X, take the opposite of Y. So A prime will be at negative 5, negative 4. And A is the answer to that. Okay, so we're translating it by that rule. So X is going 3 right, Y is going 4 down. What'll be the coordinates of C? So C is originally at 5, 1, and they're saying that X goes right 3, so that's going to be 8. Y is going down 4, so that'll be a negative 3. So D is my answer there. Okay. So what's happening in this translation? So if I look at my X's first, what's happening to get from negative 3 to 4? That's going to be 7 right. So I can eliminate these two. And to get from 4 to negative 1, this is going to be my up and down. That's going 5 down. So D is my answer. Okay, so we're reflecting on the y-axis. And they're not even asking us to do it, just what is the relationship. So reflecting on y means X becomes the opposite and Y stays the same. So let's see. It's not no relationship. Y coordinates are the same. X coordinates are opposites. It looks like C is the correct choice. Okay, this one. So now we actually have to do it. So reflected on the x-axis, same rule we just talked about. X becomes the opposite. Y stays the same when you're flipping over Y. And we want the coordinates of D. So the original coordinates of D looks like 3, 4. So D prime would be negative 3, 4. D. Okay. Coach Nelson. All right. So just read the question. So it says we're going to reflect it over that line. So this diagonal line is our mirror, which is crazy. We haven't really done one like that. So what are the coordinates of the reflected image of point C? So for something like this, I just kind of want to visualize like about where it would be. If I were to fold my graph along that diagonal line, the image is going to go up there. So it looks something like this without knowing where each and every coordinate is. So which of my answer choices have a reasonable guess for that? It can't be A, because A has numbers that are in quadrant 1. And I'm saying this is not in quadrant 1. I want something in quadrant 2. B doesn't look correct because you don't say coordinates like that with the negative on the outside. C seems reasonable. That would be in quadrant 2. So I think it could be C. And then D is in quadrant 1 again. So without really even knowing how to do this reflection, you can say that it's C just based on, being reasonable. Okay, we are reflecting across the x-axis. So the rule for reflecting across x, keep the x the same, make the y the opposite. Reflection's going like that. So A prime keeps the 4 and makes the 1 an opposite. And D is our answer there. I feel like D's been an answer a lot. Okay, so we're dilating it by a scale factor of 2. What are the coordinates of B prime? Okay, so B is at 4, 2, and a scale factor of 2 means I have to multiply those by 2. So B prime would be at 8, 4. That's D again. Okay, we are translating 7 units to the right and then reflecting it across the x-axis. And I want point A. So let's see where A is. 1, 2, 3, 4, 5, 6. It's at -6, 2. And I need to do 2 things to it. One thing I need to do is make it go 7 to the right. That means my x is going to increase by 7. My y will stay the same. The next thing I'm going to do to it is reflect it across x. So it's going to the right first. Then it's going to reflect across x. And the rule for that is that x stays the same, y becomes an opposite. Okay, so first increase my x value by 7. That's the translation. So that's going to be 1, 2. So that's where A is after my translation. Now flip it over x, 1, -2. Choice B. All right, so she has 4 corners on the picture frame. What transformation could she use to show that 1 and 2 are congruent? So that's this and this. Okay, so I think that she has reflected it over line N because it's a flip. It's not a slide. So it's not a translation because it's going in the opposite direction now. It's not a rotation because that would get from 1 to 3. It wouldn't get from 1 to 2. And it's not line M because that would get from 1 to 4. So B. Okay, now our 6 LT0 questions. Solve and graph on a number line. So I want to get rid of that 4 right away on the bottom. I don't like working with fractions, so the first thing I'm going to do is clear everything by 4. That means this gets multiplied by 4, this gets multiplied by 4, and this gets multiplied by 4. -3 times 4 is -12. When I do 3x over 4 times 4, the 4's cancel out and I'm left with 3x. So minus 3x is less than or equal to 24. Add 12 to both sides. -3x, you might have forgotten the negative in that step. -3x is less than or equal to 36. Divide both sides by -3. When I divide by a negative with an inequality, I have to flip the sign. So x is greater than or equal to -12. Yeah. Okay, so here is 0. Here's negative 12. If it's or equal to, that means the circle gets colored in. And then if it's greater, it's going to point in that direction. Okay, and yeah, that's done with that one. And now find an area of the circle if the circumference is that. Okay, so let's start with circumference. Circumference equals 2 pi r or pi d. And 28.9 equals 2 times 3.14 times r. I want to start by combining like terms, multiplying these two out. 28.9 equals 6.28 r. Divide both sides by 6.28. I'm going to use a calculator off screen. And I get that r equals 4.6. So that's the radius. Now I can go back and put it into the formula for area. Area is pi r squared. So 3.14 times 4.6 squared. Remember, you have to do the 4.6 first. 4.6 squared first, and then multiply by 3.14. And you end up getting 66.5 meters squared because it is area. Okay, that is it.